Hey guys, today we're going to look at function operations including compositions. So within this, we are looking at combining two functions, and creating a third function from it. So we can do our four operations here, adding, subtracting, multiplying, or dividing between the functions to create a new function, h of x. We're also going to look at a fifth option of using composition of two functions, putting one function inside another function. So with adding, subtracting, multiplying, or dividing, the domain of h includes all of the x values that are in the domain of f and g. In a quotient, the domain also has to exclude the x values that would make the denominator equal to 0 because we can't divide by 0. So one of the functions we are looking at is a power function that looks like y equals ax to the b, where a is any real number and b is a rational number. So ax to the first power would be something like y equals 3x. That's a linear function. Whereas ax to the second, that's a quadratic. Both of those are in the form of a power function. Alright, so for example 1, we have f of x equals 3x to the 1/3 power and g of x equals 2x to the 1/3 power. If you want to take a look on your graphing calculator or on Desmos to see what this looks like, what those graphs look like, you are welcome to. What you should see is that they're sideways of those John Travolta graphs. So they're kind of a sideways squiggle here. And that 3 and that 2 are going to affect the slope of the line, how wide or narrow that graph is, that vertical stretch or shrink there. So domain of that then would be all real numbers, or negative infinity to infinity for both of these. What we really want to find is the domain of the function after we add and after we subtract, but we need to know where we're starting with domain as well. So when we add f of x plus g of x, we're simply adding 3x to the 1/3 plus 2x to the 1/3. So we get a new function that we could call h of x would be 5x to the 1/3. So again, you can check that out on your graphing calculator, but it's that sideways John Travolta graph, so domain is all real numbers, negative infinity to infinity. There's no restriction. F of x minus g of x looks like 3x to the 1/3 minus 2x to the 1/3. So our new function would be 1x to the 1/3. And again, domain would be all real numbers. Okay, we can also multiply and we can divide. So if you want to take a look at the 4x to the 1/3 graph and the x to the 1/2 graph, 4x to the 1/3 is going to be that sideways John Travolta, so no restrictions there. So domain is negative infinity to positive infinity. But if we're looking at real values on our graph, with our g of x, x to the 1/2 is the same as the square root of x, we're never going to get a negative number, or we're never going to put a negative value into there to get a real value out. So our domain then is going to be 0, and we can include 0 because it's okay to take the square root of 0 all the way up to infinity. Okay, so f of x times g of x, then we have 4x to the 1/3 times x to the 1/2. Now remember, when we're multiplying, we add our exponents. So I'm going to change this over to a denominator of 6. So I have 2/6 times x to the 3/6. So I end up with 4x to the 5/6. So that's the 6th root of x. Again, we can't have anything smaller than 0, but 0 would be okay. So 0 to infinity. And then f of x divided by g of x. So we have 4x to the 1/3 over x to the 1/2. Well, again, let's make these the same denominator. So we have 2 over 6 and we have 3 over 6. So 2 over 6 minus 3 over 6 is negative 1/6. So we have 4x to the negative 1/6, or 4 over x to the 1/6. Well, not only can we not have anything smaller than 0, but now we can't put 0 in the denominator because that would give us a value of 0 and we would divide by 0. So our domain of this function would be everything from 0 to infinity, but we can't include 0. The last one we're looking at is the composition of functions. So f of g of x. And you can write that in one of two ways. You can write it with that open circle, or you can write it as f of g of x, that second way where you put the g of x inside in place of x. I tend to like to write it that second way. And it says use the domain of the inside function in the answer, not the outside function. Well, f of x, our domain here, so 2x to the negative 1 is the same as 2 over x. Remember, we can't divide by 0, but we could put negative numbers in there. So we could have everything except for where x is 0. So you could write that as negative infinity up to 0, union 0 to infinity. Then x squared minus 1, there shouldn't be any restrictions on what we could put inside that x squared value. So your domain here would be negative infinity to infinity. Okay, so f of g of x. What this means is anywhere I see an x in the f of x function, I'm going to replace it with g of x, which is why I like writing it in this way versus the open circle, but whichever one you prefer is okay. So I'm going to start with my f of x function. So I have 2, and then I hit x to the negative 1. Well, as soon as I hit x to the negative 1, instead of writing x, I'm going to put x squared minus 1. Then I'm going to put to the negative 1. So I'm going to rewrite that then as 2 over x squared minus 1. So that's my function. Now it says use the domain of the inside function. The inside function in this case is g of x. And from up here, we have no restrictions. But we also have to look at the domain of the answer. So 2 over x squared minus 1. Well, again, we can't have our denominator equal to 0. So where would x squared minus 1 equal 0? Well, if we add 1 to both sides, x squared equals 1. Square root of 1 on both sides, we put that square root in there, so x equals plus or minus 1. That's what it cannot equal. So then our domain, we can have anything from negative infinity up to negative 1. We can also have negative 1 to positive 1. And then we can have 1 to infinity. We just cannot include negative 1 or positive 1. So that's your domain for this one. All right, let's reverse that. Let's do g of f of x. So I'm going to start with the function g of x, and anywhere I see an x, I'm going to replace it with f of x. So I immediately get to x squared. So I'm going to do 2x to the negative 1 squared minus 1. 2 squared is 4. X to the negative 1 squared is x to the negative 2 minus 1. So then I can rewrite that as 4 over x squared minus 1. So there's my function. Now we have to use the domain of the inside function. So already we know that x can't be 0. And if I look at my answer, again, x squared on the denominator shouldn't be 0 either. So same thing, domain is negative infinity up to 0, 0 to infinity. So there's our domain. And then f of x. So anywhere, I'm going to start with f of x, and anywhere I see an x, I'm going to replace it with f of x. So I have 2, and then x to the negative 1, I'm going to write 2x to the negative 1 to the negative 1. So I'm going to take care of distributing that negative 1 in. So I have 2 times 2 to the negative 1. Well, 2 to the negative 1 is the same as 1 over 2 to the first. Then I have x to the negative 1 to the negative 1. So power to a power, I'm multiplying. Negative 1 times negative 1 is just x. So 2 times 1/2 is just 1. So I end up with x. So I have no restrictions there, but I have to use the restrictions from the inside function, which says x can't equal 0. So domain here is negative infinity up to 0, and then 0 to infinity. Alright guys, that's all I have for you for this lesson today. If you have questions, feel free to come in and see me. Otherwise, I'll see you in class.